E2 students, what's up? Prudy comes in and shares the live immediately. Wow. What confidence. On another level. Okay guys, how is everybody doing? Do we have any requests before I guess? Any requests? What part of grade 10, Itumeleng? Algebraic what? What do you want specifically? Many things in grade 10. Okay, see here I've got a grade 10 mathematics common test. You know, much common tests are coming up for grade 10 very soon. So if we look at this first question, or the first few questions, this is the questions that are here. All right, there's more coming up. As you can see, this is the rest of the question paper. Okay, but we can start right smack bang here. Okay. 1.1, indicate whether each of the following numbers is rational or irrational. Okay, there we go. Square root of 15, guys. Rational or irrational? Square root of 15. The square root of 15 is indicate whether each of the following numbers is rational or irrational. The square root of 15. Is this a rational number or an irrational number? Itumeleng Stumza says irrational. Square root of 15. Okay. 2.5. Indicate whether each of the following is rational or irrational. 2.5. What about 2.5? By the way, Itumeleng, you're 100% correct. The square root of 15 is irrational. Okay. Yeah. Itumeleng 2.5 rational. 100% correct. Itumeleng. We are on a roll so far. 1.1.3 cube root of 8. indicate whether each of the following numbers is rational or irrational. Cube root of 8. The cube root of 8, rational or irrational? This is grade 10, guys, grade 10. Okay, we're looking at a past test March paper 2024, so that we can prepare for that. Cube root of 8, rational or irrational? Cube root of 8. Okay, Dumeleng, you are saying rational. Okay, cube root of 8, yes. Okay, cube root of 8 is equal to 2. And 2 is a rational number, 100%. Then 2,33333 with the dots there. I'm guessing because we are continuing onwards. 2,333. Rational or irrational? Itumeleng is saying rational, but I'm not sure. Okay, 2,333. Yes, this is definitely rational. Okay, so let's look at it again. Square root of 15, irrational. 2,5, rational. Cube root of 8, since the cube root of 8 is equal to 2, and 2 can be written as a fraction, 2 over 1, we say that this is rational. Because remember, a rational number is a number that can be written as a fraction, where the numerator and the denominator are integers, and where the denominator cannot be 0. So this is definitely rational. 2,5 is also rational because this is what? It's a terminating decimal. Any terminating decimal where after the comma the number stops, we say that is rational. Square root of 15. As long as the number under the square root is basically not a perfect square number. Okay, 15 is not a perfect square number. So any number under the square root that is not a perfect square number, we call that type of number an irrational number. Then 2,333, guys, we have to infer that the repeating dots here are to indicate that the numbers continue in this fashion. And because we can't fill all of them in, we basically then say that this is a rational number. All recurring decimals are rational numbers as well. Okay, terminating decimal is a rational number. Recurring decimal is also a rational number. So we have 1, 2, 3 rational and 1 irrational. Okay, right. 1.2, write down 2 rational numbers between square root of 2 and the square root of 10. Again, write down 2 rational numbers between square root of 2 and the square root of 10. 2 of them. 2 what? Rational numbers between square root of 2 and the square root of 10. And they're saying show your working. Show your working. Show your working. Between 1 and 2. Write down 2 rational numbers. So these rational numbers need to exist in between these 2 numbers. They need to exist here. Exactly, to be exact. So what are the 2 numbers? And they're saying show your working. Okay. So if you think about it practically, this is the square root of 2. That is the square root of 10. So you want 2 what? Write down 2 rational numbers between. You need the 2 numbers that are in between. Okay. So what you want to do is you want to say, what are the 2 perfect square numbers that you can think about that lie between 2 and the square root of 2 and the square root of 10. Those 2 numbers, okay, think about them. 2, 4, 9, 10. Okay, so the 2 perfect square numbers are these ones. All right, but what do? You put a square root here, you put a square root there, you put a square root there. Okay, and then of course, okay, these 2 numbers lie between the square root of 2 and the square root of 10. What are these two numbers? 2, 3. Those are the two numbers, guys. Okay, those are the two numbers, these two, right? All right, show your working out. Definitely can show our working out here. We have the square root of 2. Okay, immediately afterwards the perfect square number is 2 and 3. You see? Yeah, the square root of 4 and the square root of 9 lie in between the square root of 2 and the square root of 10. So these are the two perfect square numbers. So I can conclude therefore 2 and 3 are the what? Two rational numbers. 2 and 3 are the rational numbers between square root of 2 and square root of 10. Okay, this question is asked slightly differently from the question that you guys are used to. You guys are used to the question that says, between which two consecutive integers does a particular irrational number lie? This question says, write down two rational numbers between the square root of 2 and the square root of 10, and they're saying show your working. So what I did is I first wrote down 2 and 10 at the end, and then identified two perfect square numbers, 4 and 9. Surely, guys, you can see 4 and 9 would be two perfect square numbers that lie between 2 and 10. The reason why I chose two perfect square numbers is because I am given the square root of 2 and the square root of 10. And what I want to find is the two perfect square numbers that lie between square root of 2 and square root of 10. That's what I am looking for. So then what do I do? Okay, all I simply do is I put the square roots on all of the numbers. So it was the square root of 2, of course, this square root of 4, square root of 9, square root of 10. And now I can simply go ahead and apply the square root to the perfect square number. It gives me 2. Apply the square root to the perfect square 9, I get 3. So that means 2 and 3 are the two rational numbers, okay, between the square root of 2 and the square root of 10. Hopefully you understand the word between. Okay, yeah, hopefully it makes sense. All right, are we together here? Okay, interesting question, just very logical question that we are asked today. Okay, I want to look at the question again. Write down two rational numbers between the square root of 2 and the square root of 10. Show your working. And you can see, guys, I showed my working there very nicely. You know, first wrote down the numbers without the square root, 2 and 10. All right, and then I just wrote down the perfect square number that I know that comes after 2. Okay, perfect square number that comes immediately after 2 is 4. And then the one that comes immediately after 4 is 9. Those are the two perfect square numbers that lie between 2 and 10. Then I put the square root on all of the numbers so that we can then see what these perfect square numbers will lead to. It's 2 and 3. So that's why we say 2 and 3 are the rational numbers between the square root of 2 and the square root of 10. Beautiful question, by the way. Okay, very nice question, that one. Okay, let's move on. Hopefully, Idumeleng, you are following along there, Mr. Stumza. Maybe he's gone. Yeah, it looks like he's gone. All right, interesting. Start off with someone in the live, and then as time goes by, disappear. Write down not comma 11111, which means the 1 is repeated, as a fraction for 2 marks. Write down this as a fraction. Okay, so we must be practical with this one. Very practical, guys. We must be very practical, meaning we must do it step by step, and we must show how we were able to get yes, guys, the inference here is that the ones are repeating. Okay, the ones are repeating because they are repeating for, you know, quite a few, and then they put the dot dot dot. Okay, so yes, so this is to infer that the numbers are recurring, which means that we need to then apply that method that we know we ought to use whenever we want to show that a number is recurring. Okay, so what do? We let Mr. X be equal to 0,1111, all right, a few, and we say that's equation 1. Then remember, we multiply by a power of 10, all right, a power of 10 such that we can form an equation that will basically have what? That will have the comma moved in such a way that after the comma for this equation, we will have the ones repeating. So if we multiply this by 10, we get 1,11111, that's repeating, and that's equation 2. So what we notice, guys, and this is important, we want to then notice that after the comma, we have the same numbers. And when we have that objective achieved, the objective of having after the comma the same numbers, you see, 0,111, the repetition, 1,111, the repetition. How many ones must you write? Guys, it doesn't matter for as long as we just make sure that we write sufficient ones. Okay, all right. Remember, the ones are repeating forever. Okay, so just write, you know, a few ones, all right, after the comma, and then the dot 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 will indicate that the dot 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 indicates the repetition. So all we now do is we are going to take equation 2 and subtract equation 1. So this second equation, we are going to subtract the second equation, equation 2 minus equation 1. So that means, in other words, this equation minus that one. So on the left, what is 10x minus x? What's 10x minus x? We get 9x. On the right, okay, after the comma, we have all the ones. So if we subtract the ones after the comma, we are going to have 0. But then before the comma, what's 1 minus 0? That is 1. And it's nice when you have 1, 0, because 1, 0 is simply going to give us 1. Does that make sense? So then we have x is equal to, we divide both sides by the coefficient of x, which is 9. So therefore the answer for us converting this decimal 0,111 repeated is going to be x is equal to 1/9. That is the answer, right? And it's beautifully done. Okay, so that's all we do, guys. We simply set up, okay, we look at the question, write down this as a fraction, we simply set up an equation and let x be equal to the decimal that has been given to us. Then we set up a second and sometimes even a third equation, so that we have two equations that will have the same numbers after the comma. Because when the two equations we are going to be subtracting have the same numbers, like for instance, equation 1 here and equation 2 have the exact same numbers after the comma. So then when you say equation 2 minus equation 1, the left and the right, the left hand side, 10x minus x will give us 9x. The right hand side, when we subtract this and that, after the comma, all those numbers after the comma will give us 0. And then obviously 1 minus 0 in the situation is 1. Okay, so we have 1, 0, and obviously 1, 0 can just be written as an integer value, which is 1. Now we can go ahead and divide by the coefficient that is there, which is 9, both left and right, and then get our solution. X is equal to 1/9. Okay, so the dot that is there, who is this person? Okay, world of CR7. I don't know if you have a question, or maybe that's what's happening there. You've commented with a dot. I don't know what's the dot for, but if you want to clarify something, you will ask us. Okay guys, let's move on. Factorize the following expressions fully. X cubed minus 8. Factorize, guys. Factorize. We have x cubed minus 8. There it is. X cubed minus 8. So if we are going to factorize this fully, Remember, what type of factorization is this? Okay, I usually go through a series of questions whenever I'm doing factorization. The first question I ask is how many terms are in the expression. That's what I always like asking. You know, I ask that as a matter of rule. How many terms in the expression? Someone answer that question for me in the comment section. How many terms in the expression? How many terms are in this expression? X cubed minus 8. Okay, 2. You can't say 1. Dimples, if you are saying 1, my girl, that is very scary. Yeah, my guy, my boy, is it my girl or my boy there? How many terms in the expression? 2. Second question we ask, is there a highest common factor? Well, before that we ask, should we apply the sign change rule in this question? Is there a need to apply the sign change rule? No. Is there a highest common factor? Yes, there is. What is the highest common factor? The highest common factor is 1. Okay, taking out 1, guys, makes the 2 terms we have become 1. That's something that people don't realize. Okay, that whenever you take out 1 as the highest common factor, 2 terms all of a sudden become 1. Okay, then after taking out the highest common factor, and you've taken out the highest common factor completely, you then ask the next question. In the 2 terms that you have in the bracket, is there any other type of factorization we should be applying to these 2 terms? So then you go through the list of the types of factorization you have. Difference of 2 squares, sum of 2 cubes, difference of 2 cubes, advanced trinomial where a is equal to 1. There's the advanced trinomial where a cannot be 1. Okay, so there's these grouping factorization. So now you need to look at this and ask yourself, which type of factorization are we talking about here, if any? Okay, then you see, oh, there's a difference here, but then x cubed is a perfect cubed, 8 is a perfect cubed, so therefore x cubed minus 8, this is the difference of 2 cubes. How do we factorize that? Well, when you factorize a difference of 2 cubes, you open 2 brackets. One bracket will have 2 terms, the next bracket will have 3 terms. So for my learners, I usually say that if it's a difference of 2 cubes, make sure that the first bracket has the same sign as the original bracket. Then for the last bracket, you put a plus and a plus. It's that evident, guys. You take care first of Mr. Sign. Take care first of Mr. Sign. Those letters that I usually say in the movies, sign. Then after taking care of Mr. Sign, you can take care of Mr. Number and Mr. Letter. So let's first look here. Okay, since this is a perfect cube, for a sum and a difference of 2 cubes, to take care of the number and the letter, you're going to ask what is the cube root of x cubed. Okay, for the letter you will get x. Then for the number, what is the cube root of 8? The cube root of 8 is 2. Then to get the first and the last term in in this bracket, you are going to say x times what gives you x cubed. Okanye, you square the first term, which gives you x squared. To get the last term, you square the last term, which will give you 4. Okay, and then this here will be the product, in other words, the multiplication of what? This guy and that guy. So in other words, you are going to say what is x times 2. Forget about the sign. Okay, you're going to say what is x times 2. Guys, I said you just forget about the sign. So you pretend as if the sign is not there and you just multiply the first and the second term in the bracket. Forget about the sign. What is x times 2? That gives you 2x. Guys, when you do that, you have factorized a difference of 2 cubes. That's how you factorize a difference of 2 cubes, guys. You say minus plus plus, you start with the sign, then you follow it up with the number and the letter. How do you get the number and the letter here? The letter, cube root of the first term. The number, cube root of the second term. Okay, then after that, you square this guy, you get that. You square that guy, you get that. To get the middle number or the middle term, you take the product of these two, forgetting about the sign, and you'll get what is supposed to be there in the middle. Is that done? We are finished. Factorization is complete. Okay, that's how you deal with a difference of 2 cubes. Don't stress, just follow the method, you'll be good. We're finished. Let's go on to the next question. The next question is factorize 2x cubed plus x squared minus 6x minus 3. If people have questions, I'm hoping you will ask your questions in the comment section. Don't be scared. Open your mouth and say if you want to ask the question, or you can request there and you can talk to me if you want to talk to me physically, like with a verbal voice, or you can always comment in the comment section if you want to comment in the comment section. If you have nothing to say and you are happy with what you are seeing, you just double tap on the screen and get my likes up there, guys, in the sky, so that when I get my likes there up in the sky, hopefully people who are rich can come into my live lesson and they can gift me and support me in my life goals. Because you guys, I understand you are poor, you have no money, you are debt broke, but let's get people in here who can come here and be like, I love what this guy is doing, and then they can support my life goal there with 1,000 roses that I need, with 100 whatever, call it what you want, and the many finger hearts, 20 finger hearts that I need. So thank you guys. As you do that, you are helping me a lot. I don't understand number 1. So that means you don't understand this. Who's this guy? I don't understand number 1. You don't understand this guy. In other words, x cubed minus 8. You don't know how to factorize a difference of 2 perfect cubes. Before I even ask any other questions about number 1, do you guys know what a difference of 2 cubes? Do you guys know what a perfect cube is? All right. The person who's asking why common factor is 1, Trackers of Europe, I was just mentioning that the highest common factor is 1 because oftentimes people don't actually really take that seriously about the highest common factor being 1. The difference between what you have here in these terms, I asked you how many terms were here and people said 2. That's true. Then in this line, how many terms? You now have 1 term because you've put a bracket around it. What you actually don't take into consideration as well is that by having opened these 2 brackets, there's actually an invisible one that is there. The one is invisible, but it's there, guys. The fact that we don't acknowledge it doesn't make it less real that is actually present, this one. Okay, it's like God. People believe just because they don't see him doesn't exist. So it's like the same thing with the 1. Okay. So I hope that makes sense and it's very clear. So that's why I wrote down the 1 physically. All right, I wrote it physically. There is no need to write it physically. Okay, I was just making a point that there is a highest common factor between these 2 terms. It's 1, right? But we don't often really acknowledge it, if that makes sense. Then because you have a difference of 2 cubes, I said that a perfect cube and another perfect cube means that we can factorize using 2 brackets, 1 binomial, meaning 2 terms in 1 bracket, and the other one trinomial, meaning 3 terms in the other bracket. So what we do is we write the original sign. If it was negative, we write the original sign in the first bracket. So if this was positive, we would have written positive. Since this is negative, we write negative. Then thereafter, in this bracket, we will occupy this bracket with a plus plus. That's always the case, guys, if it's a difference of 2 cubes. You first write the negative for the first bracket, then you write plus plus if it's a negative sign. Okay, then you take the cube root of the first term. If there was a number there before the x cubed, guys, we would also have to check, is that number a perfect cube? A perfect cube number, guys, is simply this. All right, 1 times 1 times 1 gives us 1, which means 1 is a perfect cube. 2 times 2 times 2, okay, how many 2's am I multiplying here? 3. That gives me 8. 8 is a perfect cube. 3 times 3 times 3, I hope you're getting the point here. 27 is a perfect cube, and so it goes. These are all perfect cube numbers. All right, so what I'm saying is that if there was a coefficient here, all right, if there was a coefficient here, then basically we would also take the cube root of that coefficient. But we must first check that both terms are perfect cubes. Their coefficient are perfect cubes. The variable is a perfect cube. The coefficient, if there's a coefficient for the second term, is a perfect cube, and the variable is also a perfect cube. That's the only way we can apply a cubic factorization if both terms are perfect cube. That's for a difference of two cubes. Now, Lolintera is asking, what if it was a positive? If, guys, we were given x cubed plus 8 to factorize, all right? First, same thing. Okay, first and foremost, I acknowledge the taking out of 1 outside the bracket. Then I open a binomial and a trinomial bracket. You know, with the signs, what I do, since this is positive, this is also positive. Then, guys, as a matter of rule, the last bracket, the last term will always be positive, just like the last term here was positive. But the only change is here. The middle term, when there's a sum of two cubes, is always negative. Is this always the case? Yes, trackers of Europe. It's always the case. It never changes. So when you have a minus, a difference of two cubes, it will always be minus plus plus. If you have a sum of two cubes, it will always be plus minus plus. Let's repeat that again. If there's a subtraction or a difference of two cubes, it will always be minus plus plus. If there's a sum of two cubes, it will always be plus minus plus. Now, trackers of Europe, all I'm expecting from you is to double tap on the screen. Make sure you are liking the live. Get my likes up there to 5,000, because you have actually now learned something and you are like, aha, oh-ho, ooh-hoo, and you are, internalizing the mathematics. It's coming, it's coming, it's coming. Then, if you want the terms, you are still doing the same thing. You want the cube root of x cubed, which is x. The cube root of 8, which is 2. You see? Then, to get the first term, you square this first term, you get x squared. You square the last term, you get 4. And then to get the middle term, you take the product of the two terms, x times 2. Forget about the sign, just say x times 2, you get 2x. There it is, done, finished. We have factorized the sum of two cubes. How nice. Okay, are we getting it? Is it coming? Is it inside? Are we internalizing? Yo. The criteria is that this must be a perfect cube, and that also must be a perfect cube in order for us to apply this opening of two brackets, 2, 3. Okay, you got 2x. Hey, you got 2x. What are you talking about? What is this guy talking about? He, you got Aaron. Some people here, I don't know. Some of you guys, when you comment, I don't know. He, you got Aaron. Let's get the English happening here. Okay, how did we get the 2x? How you Aaron? We always take the product of these two terms. The product of these two terms, for not taking into consideration the sign. Okay. If you cannot cube root the number, then it means you cannot apply the sum of two cubes or the difference of two cubes to that factorization. You cannot apply. So let me give you a typical example. If you had 2x cubed minus 8, okay, here, first and foremost, you would say, what is the highest common factor? Well, the highest common factor is 2. We take it out. Then we are left with x cubed minus 4. Now, my good friends, this here inside the bracket, even though this is a perfect cube, 4 is not a perfect cube. So I cannot continue and go further with this factorization, okay, because this guy, him not a perfect cube. Okay, him a perfect cube, him not. No balance of perfect cube, so therefore, me stop there. Okay, all right, we only apply literally sum. This is STC, sum of two cubes, DTC, difference of two cubes. Okay, maths is nice. Oh, maths is nice now, you say, trackers of Europe. You're getting me very close to that 5,000 likes, by the way. All right. Hopefully, Trackers of Europe, we can have more people here, followers that can gift us there. You know, I am hungry, guys. I'm hungry today to be supported in my life goal. I don't want to hide that and pretend as if like I'm just here to help you out. I'm being charitable and nice. Yes, I am doing all of that. But guys, if you have gifts, just pour them in. I enjoy gifts. Roses, guys. 1,000 roses. I need 1,000 roses in this life. That's my gift. That is basically my life gift goal for the night. So if before 12 o'clock, before I sleep, before I end the live, I can have that goal met, you'd be helping me out a lot. Okay. Yeah. Share it out to your rich friends so that they can help support my life goal there. Thank you very much. Okay, let's look at the next question. I think we have overspent our time looking at the sum of two cubes and the difference of two cubes, and now I'm sure you guys have now gotten the method of how to factorize the sum of two cubes and the difference of two cubes. Let's look at this guy. 2x cubed plus 2x plus x squared minus 6x minus 3. The first question we always ask when we factorize is how many terms are in the expression. Please guys, that is a beautiful question to always ask yourself. How many terms are in the expression? Start there, don't rush. Just ask how many terms are in the expression. Okay, thank you, Samu. Oh, Samu, you are the best. Samu, like, I mean, who is Samu, guys? Guys, who is Samu? I mean. 11 roses, just in one go. Thank you, Samu. Samu, thank you so much. You have no idea. You've given me energy to continue. How many terms, guys, do we have in this expression? Okay, Itumeleng, thank you. We have 1 plus sign separates. 2 minus sign also separates. 3 minus sign separates again. 4. We have 4 terms in the expression. Thank you so much. 4 terms. The next question we ask after we have asked how many terms: is there a need to apply what we call the sign change rule in this expression as we factorize? And the answer is no. Then the next question we ask: is there a highest common factor for the 4 terms that we have in this expression? And the answer, guys, is there is a highest common factor. It's 1, but 1, guys, is not significant. Okay, for the entire expression there, the highest common factor for the 4 terms is 1. But now we have to consider that we have an even number of terms. What do we mean by even number of terms? Even number of terms, guys, means that we have 2, 4, 6, 8. We have 4 terms. That is an even number of terms. So now we have to consider a type of factorization whenever we have an even number of terms. And that is a factorization that we refer to as grouping. So we are going to group the terms and then from there apply grouping factorization. So what we can see is 2x cubed plus x squared. We can group these 2 terms, and then we can see negative 6x minus 3. We can group these terms. Why? Because from both of them, from this pair of terms, there's the highest common factor that we can take out. From this pair of terms, there's the highest common factor that we can take out. And hopefully when we take that highest common factor out, we can then have what we call a common bracket. Grouping factorization is factorization that is supposed to lead us to common brackets. Those common brackets will further help us to factorize and completely factorize the expression. Okay, so we are going to group 2 is to 2. The 4 terms we have, the even number of terms that are 4, we are going to group them in the ratio of 2 is to 2. In other words, a pair is going to be made up of 2 terms. 2 is to 2. Guys, let me say this. Some grouping factorization is not 2 is to 2. Some of them can be 3 is to 3. That's when there's maybe 6 terms. Sometimes you will have 4 terms, but then the grouping will be 3 is to 1. It's possible to have a grouping factorization where you have 3 terms grouped and 1 that is just alone. And guys, it's very interesting when you have that type of grouping. So please, grouping, don't close your mind to thinking that grouping is always 2 is to 2. Sometimes grouping is 3 is to 1. You group 3 terms, maybe those 3 terms make up a trinomial, a quadratic one. that you can factorize by opening two brackets, and it's a perfect square trinomial. And then the single term that's alone is a negative term. Once you are done doing that, you actually find that there's a difference of two squares that comes about from that grouping, and then you are able to factorize further. So we must be aware and alert of the different types of grouping factorization we can get. But this one is 2:2. So let's take the two terms and take out the highest common factor. So between 2x cubed and x squared, what is the highest common factor? We are looking at the two terms. What is the highest common factor? When you take out the highest common factor, guys, we take out the highest common factor according to the sign, the number, and the letter. So let's go. Okay. The single term should always be negative. Aaron, if it is a 3:1, you'll actually find that most of the time, the 3:1 leads to difference of two squares eventually. So the last term, or the term that is grouped, that is alone, is usually in most cases negative, because it is designed, that type of expression, to lead to a difference of two squares. Hopefully I will do a question like that just on the side so that I can make the point. Okay, anyways, you look at 2x cubed and plus x squared, and you ask yourself, what is the highest common factor here? So you start with the sign. Between 2x cubed and x squared, what is the highest common factor sign? It is positive. How do you know it's positive? You look at the first term. The first term always tells you what sign you take out. So the first term is positive, which means the highest common factor sign is positive. You move on to the number. Between 2 and the coefficient here, which is 1, what is the highest common factor? It's 1. Between x cubed and x squared, what is the highest common factor? Letter. Remember, with the letter, we take out the common letter that has the lowest exponent. So between x cubed and x squared, who there between the x's, did you hear that? Between the x's, who there has the lowest exponent? Okay, it's definitely x squared. So that is why, guys, when you are taking out your highest common factor, you are taking out a positive 1x squared. In other words, you can then write it as x squared. The question then is, where is the positive and the 1? It's always there. Like God, the positive 1. God, the positive 1, the one who's always positive and good all the time. God is good all the time, positive all the time. He is there, he exists. He doesn't have to show himself every time because he's got a representative. Someone like Moses, or maybe Jesus in human form, can be a representative, but he's there. He's there, ever present, Anyways, we take out the x squared as the highest common factor. Who do we leave inside? When you take out x squared, you take out x squared, who do you leave inside? For the first term, I took out x squared, I took out two x's, I need 3 of them. How many are left? And obviously the 2 there, the 2 is left behind. So that means I have 2 as the number that's left behind. It's a positive 2. And then how many x's? I took out 2, I need 3. How many do I need to add? Just 1. So it's 2x on the left. Then x squared plus times what gives you another x squared? Well, that is 1. We close the bracket. That is the factorization for the pair of two terms, the first pair. We go to the last two terms. Guys, please be very careful. The last two terms is another pair we are going to take out the highest common factor. Remember, what did I say? Highest common factor, we take out the highest common factor sign, number, and letter. Please remember this thing. In the movies, when you are watching movies, guys, and you see these things, it's time to switch off the TV. Bad movies are not to be watched by good people like us who like maths. Rather, switch off the TV, go and do some maths, because S means, in maths, sign. N means numbers. L means letter, not the bad things that are said there in the movie. So in that order, what is the highest common factor sign between negative 6x and negative 3? The first term is negative, so we take out a sign that is negative. We go on to the number. Between 6 and 3, the highest common factor number, guys, it is 3. Letter, is the highest common factor letter? No, because x is not common. So the highest common factor, what we have there, is just negative 3. Okay, what's left inside now? 3 times what? Negative 3 times what gives you negative 6. Positive 2. Then the x is also there because it was never taken out, so it's a leftover. Negative 3 times what gives you negative 3? This is a negative times a what gives you a negative. A negative times what gives us a negative? What's the sign that's supposed to be inside there? A negative times what gives us a negative? And negative times what? Thank you, Itumeleng. It's plus 1. So it's a positive 1. Now, guys, from there, after the grouping factorization, no, it's not negative 1, Fen. It is positive 1. And negative times what gives you a negative? Guys, a negative times what gives you a negative? It's a positive sign. Be careful, guys, with the signs. So whenever a negative sign is taken out, all of the signs inside the bracket, they change. Remember the negative 6x, it was negative. Look now what's inside, it's positive. Remember the negative 3 was negative, but look what is inside, it's positive, because you take out a negative. Whenever you take out a negative, everything inside changes. The minute you take out a negative influence in your life, everything inside changes. If you take out a negative thing, you were addicted to pornography, or maybe let's say, for instance, you stole money, you were addicted to stealing, you were smoking, the minute you take it out, the minute you chuck it out, things inside start being hopeful, positive, good. You know, you take negative things out. A negative friend, someone who is negative in your friendship, you take him out, things will start being positive from within. So please, guys, take out negative things will change, you know. But look, when you take out a positive thing, nothing changes. All right, when you take out a positive thing, nothing changes as far as signs are concerned. So we have now 2 common brackets, guys. You see, now the common bracket, how many terms do we now have in this expression? How many terms? We had 4 to begin with, but when we factorize the pair, how many terms do we now have? We have 1 term minus separates 2 terms. So from these 2 terms, we have what? A highest common factor, the common bracket that we take out. What is left? On the left. Okay, if we took out 2x plus 1, on the left we are left with x squared. We took out 2x plus 1, what's we left with on the right? We are left with negative 3. You see? Can we factorize any further? Is any factorization allowed now from this bracket? Nothing. Can we add or subtract any like terms? Nothing. Any factorization we can do further here? Nothing. Any like terms that we can add and subtract? Nothing. So therefore this ends our factorization. Close quote, full stop. Woo-ha! All the marks in the back, all of them, everything that is marked with it's with us. We are going higher and higher, our level marks are going up. Everything is great. Okay, guys, I know you are liking the live. Just double tap as you show your support of liking the live. But more than that, more than just double tapping, please, guys, do me a favor. Share this live with your rich friends, your rich uncles, your rich aunties, your rich mothers. You know, that mother who is supporting you and saying, my child needs to get maths classes and all of that stuff. Those people must come here and they must come and access and gift, guys. Let them come and gift me. Come on, guys. I need support for that live goal. You know, I am obsessed with the support of that live goal. You know, 11 roses were sent by a dear supporter earlier on. I really appreciate it. I think we can add on more value there. We have 1,000 roses to basically meet before 12 o'clock hits, before I sleep. You know, so let's move on to the next question. The next question that was here, factorize the following: x to the power 4 minus 16. Okay, x to the power 4 minus 16. Thank you, Fan, for the heart me. Oh, hey, hearting the fan there. F-E-N-N, you don't mess around. You could swear you're my biggest fan. Okay, Magabe is like Mr. Q, question mark, what in the world? Who is Mr. Q? X to the power 4 minus 16, guys. Factorize x to the power 4 minus 16. What is this now? Questions that we like asking when we are about to factorize. First question, how many terms are in the expression? Guys, this question of how many terms, don't take it for granted. How many terms are in the expression, my good people? How many terms? Just tell me, I'm listening. How many terms in the expression? How many terms? 2, very good. 2 terms. Terms are separated by a plus and a minus sign. Second question, is there a need to apply the sign change rule? Okay, you can see, guys, no need to apply the sign change rule here. Next question, is there a highest common factor? Because if there is, we take it out. If there isn't, we proceed further. All right. So is there highest common factor? Sign, yes, positive, because the first term is positive. Number 1, yes, number 1 is you. So basically we can say x to the power 4 minus 16 in brackets. We know who's outside. We don't have to write him there. He's always there. He's always present, and he's positive. The positive one, he's always there. From 2 terms, we now have 1 term because we've put the 2 terms inside a bracket, taking out the highest common factor, which is 1. Then the question is there any other type of factorization that can be applied with what is inside? What do you guys see inside? Now I'm going to wait for someone to comment in the comment section and tell me what type of factorization should be applied. We said we have DOTS, difference of 2 squares, sum of 2 cubes, difference of 2 cubes, advanced trinomial where a, the coefficient of x squared term, is not 1, trinomial, quadratic trinomial where a is equal to 1, grouping factorization. So what are we seeing here? User 7768437846840 is saying dot, difference of 2 squares. Fen is also saying difference of 2 squares. Seems like people are saying difference of 2 squares. Okay, and Lenong is coming in here and asking me, what did you get the 4x for? Are you kidding me? This is a question, my man. Okay, the question is saying factorize. This is x to the power 4, and now you're asking me, where did I get x to the power 4 from? Lenong, when you should give me a rose there. For asking me that question, it's a rose, my guy. It's a rose. It's a rose, and I can see you're a level 1 gifter there. So the rose, my guy, just send it. I'm waiting for that rose. Share the live, guys. Please share the live. I really appreciate the sharing of the live. X to the power 4 minus 16, difference of 2 squares. So why do we say difference of 2 squares? Because remember, any variable, by that I mean any letter with an even exponent. What do you mean by even exponent? 0, 2, 4, 6, 8. All of these numbers are even numbers that are divisible by 2. Okay, so any variable with an even exponent is a perfect square. PS chocolate. PS. Any variable with an even exponent is a perfect square. So that's why we say this is a difference. X to the power 4 is a perfect square. 16 is definitely a perfect square. Why? Because any number that is formed by a multiplication of a natural number by itself is a perfect square number. So a perfect square variable is a variable with an even exponent. But a perfect square number is a number formed by multiplying a natural number by itself. For instance, 4 times 4 gives us 16. So therefore 16 is a perfect square number. Does that make sense? I hope it makes sense, guys. So this is a difference of 2 squares. That's why we say that. So what do we do with a difference of 2 squares? Guys, we open 2 brackets. 2 brackets of 2 terms. Okay? Brackets of 2 terms. And then what do we do? Since it's a perfect square, guys, we take the square root of x to the power 4 to get the first term in each bracket. What is the square root of x to the power 4? It's x to the power 4 over 2. The 4, when we remove a square root, we put as the denominator 2, because square root means division of the given exponent by 2. So what does 4 divided by 2 give us? It gives us 2. So therefore x squared is going to be featuring as the first term in each bracket. Are we together? Hey, I hope we are together, guys. Then the minus sign, when there's a minus sign, guys, that means in the brackets we are going to have different signs. So a difference, remember the word difference means minus. A difference means different signs. A difference means different signs. Then we are going to take the square root of 4. What is the square root of 4, guys? Your square root of 16. Yeah, I'm saying square root of 4. The square root of the last term. Forget about the sign. So different signs means plus and minus. I always like starting with the plus and ending with the minus. Not starting with the minus and ending with the plus. I like starting with the plus, ending with the minus. Different signs. The square root of 16, it's 4. So I put 4 and 4. Alright. Now, I know some people will say, that was good factorization. I am done. And they smile and they like, let me underline and move on to the next question. But then they're like missing out on a big thing. So what you do is, after you are done with this, go and look at the first bracket and check, is there any factorization that can be done with this bracket? And the answer is any factorization that can be done in the first bracket? The answer is yes, no? Any factorization that can be done in the first bracket? The answer is no. We cannot do any further factorization with the first bracket, guys. We can't do any factorization with bracket number 1 because this is a sum of 2 squares. A sum of 2 squares is unfactorizable. What about the second bracket? Is there any work that can be done in the second bracket? Is there? What do you see in the second bracket? We see a difference. And then x squared is a perfect square. 4 is a perfect square. So we have here a difference of 2 squares. So what do? We keep x squared plus 4 as it is. Then we open 2 additional brackets. For what? For this difference of 2 squares. Are we together? Then remember, what did we say difference means? We said difference means different signs. So what are we going to do? We are going to put a plus and a minus sign as a matter of rule, guys, because for a difference of 2 squares, your signs are going to be different. So I always say put the plus sign first and put the minus sign last, just in case you have another difference of 2 squares so that you can take care of it. If not, then I guess it's not a train smash. It is not a train smash. Okay, then we ask ourselves, what is the square root of x squared? So once again, that is like saying x to the power 2 divided by 2. Where does this 2 in the denominator come from? It comes from the square root. Okay, if this was a cube root, we'd say divide by 3. Since it's a square root, we say divide by 2. Where does this 2 come from in the numerator? It is the exponent that existed for the variable inside the square root. What's 2 divided by 2? It's 1. So that 4 means that is x. So we're going to write x, and we know that x times x gives us x squared. Then, what is the square root of 4? What is the square root of 4, guys? It is 2. So that means we're going to write 2 and 2. Now, once we've done that, the question is, are we done factorizing? Or can we still factorize further? That is the question. Can we factorize this bracket? You answer. Can we factorize this bracket? You answer. Can we factorize this bracket? You answer. 1, 2, 3. You write down. No, no, no. Yes, yes, yes. Yes, no, no. No, no, no. No, no, yes. No, yes, yes. No, no, no. Velandra says x plus 2 CF. What is that? No, 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 guys. No, no, no. We are done. Factorization is complete. Factorization is complete. Right? So For grade 10 students, guys, please, we end right there. We do not continue any further because let us go originally from the beginning. What did we say when we were approaching this question? First question we always ask when we're factorizing, how many terms in the given expression? So we counted 1, there's a minus sign, 2. We said there were 2 terms. Second question, should we apply the sign change rule? No. Is there a highest common factor? Yes. We took it out, the positive 1, and we wrote x to the power 4 minus 16 in brackets. Second question, can we factorize the 2 terms inside the brackets using any other factorization method? The answer was yes. What method? We then said this here is a typical difference of 2 squares. D-O-T-S. Difference minus sign of 2 what? 2 squares, meaning x to the power 4 is a perfect square. Why? Because any variable or letter with an even exponent qualifies as a perfect square variable. Any variable or letter with an even exponent. What is an even exponent? Any exponent that is 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, all those numbers that are divisible by 2, those would be even number exponents. Those are all perfect square if there's a variable with those numbers as an exponent. So this is a perfect square. It qualifies because of that. 16 is a perfect square number. Why? Because it is formed by multiplying a natural number by itself. So 16 is a perfect square number. So that's why we call this a difference of 2 perfect squares. So we can factorize it. How? We open 2 brackets. Immediately we open those 2 brackets. We know they are both 2-term brackets. 1, 2 inside the bracket, 1, 2 inside the bracket. So we put a plus sign and a minus sign to kick off the story. Signs, positive and negative. Why? Because difference for the sign, the minus sign means what? It means we are going to have different signs. Where? Inside the bracket. So we write a plus sign first and we follow it with a minus. That's where we start. We start with the sign. Then we follow it up with the letter, the number, and the letter. Take the square root. Remember, difference of 2 squares. We take the square root of x to the power 4, which means x to the power 4 divided by 2 when we remove the square root, which gives us x squared. Then we write the x squared as the first term in each bracket. X squared, x squared. Then after that, we take the square root of 16. Square root of 16 is 4. We write 4 in each bracket. 4. All right. Then we check. Can we factorize the bracket further? This one? No. Can we factorize this bracket further? Yes. Why? Because we have another situation of a difference of 2 perfect squares. So then what do? We bring down Mr. x squared plus 4 because he cannot be factorized further. We then open 2 additional brackets for Mr. x squared minus 4. We write a plus sign in the first bracket and a minus sign in the second. Why? Because difference, the minus sign means different signs. Plus, minus. Then take the square root of x squared. What does that give us? An x. So that means we write x and x in each bracket as our first term, because x times x gives us back x squared. Then, what is the square root of 4? We get 2. Therefore, we write 2 and 2. And that means we are done with the factorization, because what do we see? Can we factorize this bracket further? No. Can we factorize this bracket further? No. Can we factorize this bracket further? No. So we end right there. Amen. Hallelujah. Amen. That's it. Any questions, guys? Any questions for this difference of 2 squares questions, which is like one difference of two squares after another. Guys, are you feeling the vibe? Are you feeling you guys becoming more buffer and buffer? You're becoming more mathematically buff? Can you feel the rise of the muscles as you become more mathematically buff and competent? Guys, please, if you're feeling more mathematically competent, I would appreciate your support. Double tapping on the screen definitely goes a long way. Supporting my life goal definitely goes a long way. Sending that rose if it's possible in your side, and even sending more if you feel like you are feeling that much joy. That would be great. That's really acceptable here. All right, your heart me's are heart me's, and they heart me a lot. Finger hearts are great. Galaxies are amazing. All right. Okay, so anyways, let me shush it now. Okay, I hope we got that factorization going nicely there. All right. Right, I want to expose you to this question so that I can actually proceed and move on to another one just shortly. So guys, if you look at this question, a squared minus 4 plus 2ab plus b squared. So once again, what do we have here? And the question says factorize. What we have here, guys, is a typical situation where we are like, okay, we have 4 terms, because we usually ask the first question, and that is, in the expression that you are given, how many terms are in the expression? That's what you always ask. So how many terms do you see in this expression? You see 4 of them. 4 terms. The next question is, can we apply the sign change rule here? Can we apply the sign change rule in this question? And the answer, guys, to that question is no, we don't have to. 3 is the highest common factor. The highest common factor for all 4 terms is 1. But then the thing is, it's not significant. It doesn't really help with much. So then we have to then divert and deviate and then ask ourselves, is there anything else that we see from this expression that could basically assist us in factorizing it further? And in our heads, we immediately think grouping might be of assistance here. Okay, some of you may even see that, oh, this is a squared minus 4, and so you may be tempted to want to group a squared minus 4 and factorize it as a difference of 2 squares, which, okay, it will give you a plus 4 into a plus 2 into a minus 2, plus here maybe you take out a common factor, that is b, you get left with at a bracket that is 2a plus b. But then you look at that and you're like, what can I do further? And in all honesty, guys, there's nothing more that you can do. So even that type of factorization in that way is not going to be assisting us too much. So then that means you need to think a little bit more. So if we look at these terms again, we are like a squared we can see. Please be aware of the terms you have. Plus 2ab you can see. Then you can see plus b squared. Sean, you are the best. Sean shreds 11. Thank you so much for the 5 roses. That adds to the 11 that we had, brings the tally up to 16 roses out of 1,000. That, I want to calculate the percentage of roses that I've received so far, because 16 out of 1,000, if you say 16 over 1,000 and you times it by 100, that should give you the percentage of roses I have so far. Okay, hopefully we can get more coming in. Thank you so much, Sean Shreds, really appreciate it. So now, guys, here we must then rethink and reorder these terms so that we can see something else. And that's why I was saying to you guys that in some situations you have to think a little bit outside the box and see things that need to be seen. So what I'm going to do is I'm going to group this to terms. 3 terms is to 1. That's what I was talking about earlier on, saying that some grouping requires you to see 3 is to 1. So we have 3 terms here is to 1 term. These 3 terms here are actually what we call a perfect square trinomial. PST, I usually call it. Perfect square trinomial. We can factorize this to become this. So if I open two brackets here, please take note what I'm gonna be showing you here. We have a and a, which gives you a times a, which is a squared. The b squared, b and b, which will give you the b squared. This positive sign means we are going to have the same signs inside the bracket, but according to who, guys? Okay, a positive last term means same signs, but the same signs are according to who? The sign of the middle term. So that means my same signs are both going to be positive, and in my head I'm thinking there is a number 1 here. What are the two numbers that I can multiply together which will give me 1, but then when I add them will give me 2? Okay, what are the numbers that I can write as a coefficient of b, which when I multiply will give me 1, but when I add them will give me 2? So Spider-Man, I'm sure you can say, and you can say confidently, that the number there is 1. So that means that 1b is safe. Guys, even if I don't write the 1, just by writing b, there is a 1 that is before b. Okay, so the addition of 1 and 1 will give me that 2. Remember that the a and the b together, when I add, when I FOIL, I'll still get my 2ab intact. So that is minus 4. But simplified, a plus b, you can see these are similar brackets. So that means this is a plus b squared minus 4. That's why I was saying, guys, that now when you re-look at this 3 is to 1 has led me to basically factorizing my perfect square trinomial to become a binomial bracket raised to an even number. So now I have a bracket which is one term and then a minus sign and a 4. So what I have now is a difference, difference of what? This is a perfect square bracket. Why? Because as a bracket inside the bracket with a plus b, this is all raised to an even exponent. Any bracket raised to an even exponent, guys, is a perfect square bracket. I repeat, any bracket raised to an even exponent is a perfect square bracket. So that is why we say we have a difference of y2 squares. This is a perfect square bracket, and 4 we know is a perfect square bracket. So what am I going to do when I factorize this? I'm going to open 2 brackets. Okay, because I can see dots in the mix. Hey guys, factorization is sweet. All right. Yeah. Yo, yo. Right? So what we do now, guys, with a difference of 2 perfect squares, is we put a plus here and a minus sign there. We are going to take the square root of a plus b squared. When we apply the square root to a plus b, the whole thing squared, what happens, guys? The square root apply to the square. Okay, a plus b to the power 2 over 2 will lead to a plus b, because 2 divided by 2 is 1. So a plus b is going to occupy my first term status. A plus b is going to occupy my first term in each bracket. That is the square root of a plus b squared. It is a plus b. Then I'm going to take the square root of 4. Square root of 4 is 2. So I'm going to put 2 and 2. Okay. Get difference of 2 squares in one is. Get difference of 2 squares. Hey, hidden difference of 2 squares. Where you have to group 3 terms is to 1. Hey, bana. Then now you remove that first bracket, guys. That one. Alright, remove. There's a 1 that comes before the a. So you say a plus b plus 2. 3-term bracket. Ha, bana. Kimetsile, ntate. Sean Shreds, I, my guy, you are making my day. I really appreciate you. I have no idea. I have no idea. Then this A plus B, guys, this one, this guy, this one. I also remove his bracket. I write A plus B minus 2. Ndwe is vectorized and finished, Baba. Ndwe is vectorized and finished. So, grade 10s, what I'm saying to you is that you must be aware of such. I tell you now, examiners love this question. Do you know why? Because most learners don't even know when it hits them that this grouping requires a 3:1 conceptual understanding. When you know 2:2, you know that one. That's what you know. When you don't know the other ones, Baba. You don't know the other ones. But the other ones are crying and they're saying, pay attention to me. You must also know me. Know me too. Yo, I Sean Shreds, you're making my day, my guy. You. Aye. Guys, I want to calculate the percentage of those roses. You. Ndate, Sean. Choo. My goodness. That's 149 plus 5. Hey, Baba. 149 plus 5. 154 divided by 1,000 times 100. My leader. 15.4%, my leader. You have a. Yeah, thank you, my guy. I really appreciate you. Thank you. I really appreciate those roses. I know they come from a very good place, you know. Yeah. No, thanks, Baba. Thanks. I think we can move on now. Let's move. The question paper that I had, guys, was not about factorization. It's just that factorization caught my eye. Let's move on. Now we are moving on to some simplify. Simplify the following expressions fully: 2x minus 1 into x squared minus 2x plus 1. I think, guys, these ones, this is nice, straightforward stuff, right? Where we are using what I call the distributive property. And when we do so, we apply SNL. After doing so, we distribute to remove brackets, all right? And then we add and subtract the like terms that result. Same here, all right? Same here, all right? And these are marks, guys, for grade 10. Which grade? Grade 10 is grade 10 is Kanya, but this is basics, for grade 11 and 12. So it's that kind of maths. What were you looking for, Zamakanya? Because Zamakanya, it's like you were asking because you were looking for something. Is there a particular grade of maths you were looking for? Let me be of assistance to you tonight if that is possible. Yeah, right. Yeah. Yo. Sean Shreds left me feeling nice. Sean Shreds, if you are here, my guy, please let me know in the comment section who are you and all of that stuff. I really appreciate that. It would be really nice to know. Guys, we are asked to simplify here. Simplify. So let's not forget 2x minus 1 into x squared minus 2x plus 1. All we do here is we play Mr. Distribution. 2x goes there. And when he goes there, we know that we multiply the sign, we multiply the number, we multiply the letter. Let's not forget those movies we shouldn't watch as we do this. We are distributing here. Okay, DL, distributive law. And whilst doing so, we multiply the sign, multiply the number, multiply the letter. So this times that, we multiply the sign. Positive times a positive is a positive. Then we multiply the number 2 times. We know that there's a 1 that we can't say. 2 times 1 is 2. Then x times x, the letter. Remember, when you're multiplying letters, especially when they are the same base, variable is the same, we keep the letter. We add the exponent. Remember, guys, there's a 1 there. There's a 2 there. So you keep the letter. Then you add the exponents. 1 plus 2 is 3. So that's why 2x times x squared gives you 2x cubed. You are not done. You distribute the 2x to the negative 2x now. You see the 2x does his job. he's finished and done. That's what he gets. 2x is not done. He goes to the other person in the bracket. Positive times a negative. You see, we start with sign. Positive times a negative, is negative. We move on to the number. 2 times 2, is 4. We move on to the letter. X times x. We keep the letter x. We add the exponents. Remember, the exponent here that you don't see is 1. The exponent that you don't see there is 1. So 1 plus 1. 1 plus 1 is, you guys, the song has been going on the whole of the festive season. 1 plus 1 is snow. Go. By now, you should be knowing what 1 plus 1 is. You know? 2x, we are not done. We multiply with 1. Positive times a positive, is positive in 2. We move on to the number. 2 times 1, is 2 in 2. Then x, the only letter that's there. We are done distributing 2x to how many terms? 1, 2, 3. And every time we were looking at the sign, the number, the letter as we multiply. We move on to the next term, -1. We do the same thing to -1. We send him out to all 3. And as we do so, we multiply sign, number, letter. Theorem of Pythagoras states the theorem of Pythagoras applies to your right angle triangle, Mr. Gift. All right. So if you have triangle ABC, theorem of Pythagoras was basically saying, let me just show you, a square here, a square there, a square there. The area of each square, you know, most is side times side. So what theorem of Pythagoras says, it says that the square of the longest side, which is the hypotenuse, the side which is opposite your 90 degrees, we say that the square of the longest side, which is your hypotenuse, is equal to the sum of what? The square of the other 2 sides. So BC, your other side is BC squared, and your other side is AB. You square it as well. So theorem of Pythagoras says that the square of the hypotenuse, which is usually the longest side, is equal to the sum of the square of the other 2 sides. So BC squared plus AB squared gives you AC squared. AB squared plus BC squared gives you AC squared. AC squared is equal to BC squared plus AB squared. AC squared is equal to AB squared plus BC squared. That is the theorem of Pythagoras for you. Okay, let's go back to the problem now. Hopefully you are fine there, Mr. Young Man. -1 times x squared and negative times a positive, is negative in 2. 1 times 1, is 1. X squared next door. -1 times, we move on. -1 times -2x. Negative times a negative, is positive in 2. 1 times 2, is 2 in 2. And then x, is x next door. -1 times +1. Negative times a negative, negative times a positive, is negative in 2. And then 1 times 1, is 1. Now we look for the like terms and we add them. We group them and add them together. 2x cubed is alone. He has no friends. Right. -4x squared is a friend to -x squared. So we bring them together and we add them. -4x squared, -1x squared. They are friends. 2xc and plus 2xc, they are friends. We bring them together, we add them. 2x plus 2x, we bring them as they are. -4x squared was negative, -1x squared was negative, we bring them as he is. Plus 2x, we bring them as he is. -1 has no friend, he's alone. He is a loner, has no friends. Right, then we add the like terms. 2x cubed. Now, what is -4x squared minus 1x squared? Hey guys, hey, people do funny things as they add these things. We call these like terms. Why do we call them like terms? Like terms are terms that have the same letter and the same exponent. That's why we can add them. It's like two kids that have the same uniform. When the two kids wear the same uniform, we can count them as belonging in the same school. Itumeleng, your answer is incorrect. It's not negative 3x squared. This is the thing about people adding integers. So whenever we're adding like terms, we keep the variable and its exponent as it is. It does not change. Just like school uniform does not change if you are counting the number of kids. The school uniform doesn't change. All right. But then negative 4 minus 1. What is negative 4 minus 1? Guys, some of you are struggling. So you take the calculator and you say negative 4 minus 1 so that you can be accurate. Guys, you see the answer that you get there? So different from that negative 3 Itumeleng typed in the comment section. Okay, and it's so different from the positive 5 that Itumeleng typed in the comment section. Be careful, guys. Be careful. I was teaching the grade 8s today and saying that if you are dealing with the addition of numbers that have the same sign, this is the addition, right? You hide the signs. You add the numbers if the signs are the same. So you say 4 plus 1, and then you take the sign of the numbers. You add a negative 5 to that 5 that you got. What did I say? You hide the signs. So pretend as if the signs are not there. Then what do? You add the numbers because the signs are the same. Then what do you get when you add those numbers? You get 5. Then you take the sign of the numbers that we given. So you get a negative 5. That's how you do it using your head. Because some of you are writing wrong answers. Yes, son. Then use the calculator, please. Plus 2x plus 2x. You see, these have the same sign. What do? I hide the signs, add the numbers, take the sign of the numbers. That's why the answer is 4x. Then lastly, negative 1, he just stays there alone. This is the end. We cannot add this with this or subtract it. Why? Because these are not like terms. Even though they both have x, the exponents are different. We cannot add those terms. They are unlike terms. The x squared and 4x, you cannot add these two. Why? Because even though the letters are the same, the exponents are different. They are unlike terms. We cannot add unlike terms. Yeah. So we are stopping here. Guys, please, my life goal, if you can send something for the live goal, guys, please, I beg you. The goal, guys, is 1,000 roses. I have 165 already, thanks to Sean. Sean really cracked and crammed the goal there, made a difference. If anyone can spare a rose, guys, there's 180 of you. If a person can send at least 1 rose, I really appreciate it, guys. It goes a long way, this thing, as I do the live lesson. It's really encouraging. Right, let's move on. I think we are done with that one. 3x plus 5. We are asked to simplify. Guys, we are asked to simplify. 3x plus 5, the whole thing squared. So how do we simplify this one? Okay, it's very important to first note, inside the bracket, what are we seeing? A 3x and a what? A plus and a what? And a 5. Inside the bracket, how many terms do we have? We have 1, 2 terms. If that is the case, guys, then like Ntombe and Itumeleng are saying, and unfortunately I think it's my restriction in the comments that is basically limiting them from actually showing those comments. I'll just approve those comments. We must open 2 brackets, guys, just like it says. Hi Sean, Shem. Sean, you are holding up the country right now. You are the one that is sustaining the country, my guy. Thank you so much. I see those roses there, only 30 of them. Thank you, my guy. We're officially there, 200 roses there. I think definitely 200 roses. Guys, I love working in percentages. You know what I mean? Just to see what percentage is that. We are officially have thrashed 20% of the rose goal, so I really appreciate it. Thank you, Sean. Thank you so much. Oh my goodness. And and Thor. Is it THAR? Owenkosi. Owenkosi. I really appreciate it, Owenkosi. Okay, so let's proceed. So like you guys said, we open 2. Why are we opening 2 brackets of 3x plus 5? It's because 3x plus 5 is squared. What does the exponent mean? It means repeat 3x plus 5 and multiply this number of times. You know what I mean? We repeat the multiplication this number of times according to the exponent. That's what the exponent means. Then what do we know here? Once again, we are going to play Mr. Distribution. Take 3x, send him here. Take 3x, send him to the other term. Not only that, take 5, send him here. Take 5, send him there. And as we do so, we know we're applying the distributive law or property, applying multiplication of S, N, L, sign, number, letter. Let's go. The positive times a positive is positive. 3 times 3 is 9. X times x, keep the variable x. When we are multiplying, we add the exponents. Remember, there's a 1 and the 1 there that we can see. 1 plus 1 is 2. Snoko. Lala snoko. Bulama boto. Okay, 3x times 5. 3x times 5. Positive times a positive, give positive 12. 3 times 5 give 15 and 12. Odd numbers are numbers that are not divisible by 2. So for instance, 1, 3, 5, 7, 9. Okay, because all the ones that are in between 2, 4, 6, these are even numbers and they are divisible. In other words, 2, okay, these can be divided by 2 without leaving a remainder. But these ones, 1, 3, 5, 7, those are odd numbers. They cannot be divided by 2 without leaving a remainder. So that's what we call odd numbers. Odd numbers are numbers that cannot be divided by 2 without leaving a remainder. Okay, so 9x squared plus positive times a positive give positive. 5 times 3 give 15, and then the x next door. We are done with 3x times 5. Then we move on now to positive 5 times 3. Positive times a positive give positive. 5 times 3 is 15, and then of course the x next door. Then lastly, positive times a positive give positive and 12. 5 times 5 give 25 and 12. Then we here, guys, and we can add like terms. Okay, so now that we have done that, we can say 9x squared, guys, 15x plus 15x, these are like terms. Why do we know these are like terms? The x and the x make it such that we know that they are like terms, because the x and the x are there and the exponent of the x's are the same. So therefore, what can we do? We can go ahead and add these like terms. Okay, so 15x plus 15x will give us, we keep the variable, we add the coefficients. What's 15 plus 15? It's 30. And then we write the 25 at the end. Can we add and subtract any other terms? No, you can't add 9x squared and 30x. Why? Because even though there's an x and an x, the exponents are different. Guys, when the exponents are different, you cannot add those like terms no matter how much you want or desire or feel, or you know, you may feel whatever you feel, but your feelings don't matter here. It's facts over feelings. All right, this is a factual thing, logic. So please, no feelings here. All right, I'm not being personal. Okay. All right, let's move on, guys. We have an exponential expression that we need to simplify there, 1.5.3. Okay, I'm hoping that we've done exponents, we've done them at school. So here we have a 2 to the power x. Let's write it down. Simplify 2 to the power x minus 2 to the power x minus 2 as an exponent over 2 to the power x plus 1 minus 2 to the power x. Okay, so guys, the first thing we need to say is, okay, we have an exponential expression. How many terms do we have at the top? And I like asking this question. How many terms do we have at the top? We have 2. How many terms do we have at the bottom? we have 2. So there are 2 terms each. The minute we see a minus sign in between the terms, then it means that we need to then consider in our heads factorization. But we can't consider a factorization here until we can assess what it is that we have. We have a 2 to the power x. This is a prime base number. This is a 2 as well. It's a prime base number. If we look at the x, the coefficient of x, the exponent, we have 1 and 1. So in your head, that suggests the kind of factorization where the variable exponent has the same coefficient. All right, that suggests to us that we are going to be applying common factorization. If the variables for the same prime base have the same coefficient, okay, then it means there's some sort of factorization that we are going to be applying, as well as in the denominator, because 2 to the power x, there's a 1, and then 2 to the power x, there is a 1. So what we are going to do, we are going to first split, or in other words, expand our base 2 for the second term. 2 to the power x minus 2 can be written as 2 to the power x times 2 to the power negative 2. DJ Kens, yes, I do work with exponents for grade 9, definitely, right? Exponents for grade 9, or most definitely, I do. But unfortunately, it's just that I'm not doing that now. This is exponents for grade 10. Grade 10s are doing this kind of this exponential work, all right? Then we are going to do the same in the denominator. We are going to split or expand. That's what we call it. Okay, so what I've just done here, I've split, or they call it expanding. It's like applying the reverse of law number 1. You know how law number 1 says of exponents, if you are multiplying same bases, you keep the base, you add the exponents. It's like I'm applying this law in reverse. Okay, the base raised to an addition of exponents means that I can write the base separately as a to the power m times a to the power n. So in the same sort of language, 2 to the power x minus 2 can be written as 2 to the power x times 2 to the power negative 2. 2 to the power x plus 1 can be written as 2 to the power x times 2. Why are we splitting? To prepare for factorization. We're not splitting or expanding for the sake of splitting and expanding. We are splitting, expanding to prepare for factorization. And there are different types of exponential factorization. There's highest common factor, there's difference of 2 squares, there's many others. So we can then look at the top again and ask ourselves, what is the common factor in the numerator? Do you guys see what the common factor is in the numerator? Can you see a common factor? All right, I hope you can. 2 to the power x is here, 2 to the power x is also on this side. So I'm going to take out 2 to the power x. But when I do for the first term, what am I left with? 1 on the left minus what on the right? 2 to the power negative 2. Over, let's look at the denominator. Do we have a common factor here? Yes, we do. What is it? It's 2 to the power x again. What are we left with on the left? 2. What are we left with on the right? Negative 1. We close the bracket. Then we say equal. Now, after factorizing, highest common factor, as we could see, the base with the variable exponent was common. The base with the variable or the letter exponent was common. We took it out. Then we were left with certain things inside each bracket. When we took out the 2 to the power x at the top here, for this term on the left, we're left with 1. 2 to the power x times 1 gives us back this. For this on the right, we're left with 2 to the power negative 2. Down here, we're left with 2 minus 1. Now, what can we do? Cancel. Cancel what? This with that. Why can we cancel this with that? Why can we cancel? I'm going to pause for a little bit. I want you to think about it. Why is it possible to cancel? And my question is, can we cancel this 1 and this 1? If so, why? If not, why? Some food for thought. Answer me in the comment section. I'll be back. Okay, Lorraine M says, because they are like terms. Okay, guys, because they are common factors. All right, here's the thing. Just some food for thought. If I had 3 times 2 over 2, all right, I am allowed, if 3 has the relationship with 2 of multiply, all right, and then this 2, let's say there's a 2 and a 7, and this 2 has a relationship with 7 of multiply. This is division. I can cancel these 2 because the relationship between this 3 and this 2 with this 7 and this 2 is multiply, so therefore cancellation can happen freely. But let's say I had something like this. The relationship with this 3 and this 2 is one of plus, and then the 6 is divided. All right, so can I cancel the 2 and the 6 is my question. No. Okay, so here we can cancel because it is not across a plus or minus sign. Guys, as long as it's not across a plus and a minus sign, we can cancel. In other words, we can divide. And what's get left in the place of 2 and 2? Obviously, 2 divided by 2 is 1. But we cannot cancel across an addition and a subtraction sign. We can't cancel this 6 and this 3. No. We can't cancel this 2 and this 6. No. Why? Because it's across an addition and a subtraction sign. So here, the 2 to the power x has a relationship with all of this in bracket, which is multiply. This 2 to the power x has a relationship with 2 minus 1, that is also multiply. So cancellation can happen freely. We are left with 1 and 1 in their place. That can happen because it's not across or next to an addition or a subtraction sign. That's why it's possible to cancel. I need you guys to have that fixed in your minds, because oftentimes learners think that as long as you have something similar at the top and the bottom, you can cancel. But that's not always true. It's only true when it's not across an addition or a subtraction sign. Then what are we left with? 1 minus, you can write 2 to the power negative 2 as 1 over 2 squared. Where does that come from? A to the power negative 1 is equal to 1 over a. I repeat, a to the power negative 1. Okay, maybe we need to get an understanding why all of a sudden do we write the answer 1 over a. This here, I need to show you what you don't see. Before the a, there's a 1. Underneath the a, there is a 1. These are the invisible ones that exist next to the a and below the a. That's things that we don't usually talk about. So the rule says if you have a base raised to a negative exponent, what happens is this base changes position. So it moves from the numerator to the denominator. The exponent sign then changes to positive. Who, when the a leaves, gets left behind? The coefficient, which you don't see, which is 1. That is why the answer is 1 over a. So a to the power negative 1 is 1 over a, Because when a base is raised to a negative exponent, the base changes position from the numerator to the denominator, and the exponent sign changes from negative to positive. In fact, let's just say the exponent sign just changes from whatever it was to another sign. That's very important. So if I was to say a to the power negative 2, the answer is going to be 1 over a squared. I need you guys to understand this is a rule and a definition that applies to all negative exponents. Why? Because we don't ever write final answers with a negative exponent. So therefore we need to know this rule. Okay. I want to say if we had 1 over a to the power negative 2, our answer would be a squared over 1, which is actually a squared. The base changes position from the denominator to the numerator. What happens to the exponent? The exponent changes sign to positive. That's why the answer is a squared. Okay, so understand that 2 to the power negative 2 is simply 1 over 2 squared. It's all there in the numerator, and 2 minus 1 is 1. We then proceed and say 1 minus 1 over what's 2 squared? It's 4. But remember, if it's divided by 1, guys, division by 1 basically has no significance. So then we can proceed and say 1 minus 1 over 4. What's 1 minus 1 over 4? It is actually, guys, you can grab your calculator at this stage and say 1 minus 1 over 4. And you can use your calculator to get the answer. The answer is 3 over 4. And you win. That's it. Done. Finished. Okay. Hi guys, I think let me hold it right here for today, for tonight. I think people need to wake up tomorrow morning, there's school to be had. Yeah. So I hope the session was helpful to some degree, and that you guys will keep on practicing the maths, do the most in your space, and just keep on keeping. The maths is really, I think, it's really easy if one is really taking the time to really understand each concept as it comes, and then practices to a very large and great extent, and makes sure that they master everything that needs to be mastered. Okay. So otherwise, thank you so much, guys. It was a very sweet live. I really appreciate again the gift. Sean Shreds was really generous today. I really appreciate. If you're still around, really appreciate you, sir. But if you're not, thank you anyways. And thank you to all the other generous gifters there that really made the live quite exciting. That gift code really was attended to today, I must say. I think the best it has ever been attended ever since I put up the live goal. So thank you so much. Means a lot, means too much. To everyone that contributed to it, Fan as well with the heart me, and everyone else that contributed. Thank you so much. Lorraine, you're welcome. Thank you for your time as well. Thank you for joining in, and thank you for participating, asking questions. Participating and just being active in the comment section. It really goes a long way when people are here and they are active. And otherwise, guys, we'll see each other again another time. Have a great night and rest well. May you master the maths.